Before we get started, which of these are triangle congruence postulates? In other words, if triangles have three matching sides, does that guarantee that they're congruent? What about if they have two matching sides and a matching angle between those sides? Or two matching angles and a matching side length in between? And if you're not sure about any of these and you'd like to review, then click over here. Right, all three of these are congruence postulates. Now let's take a closer look at angle-side angle, or ASA. This says that if two triangles, like these two triangles here, have two matching pairs of angles and matching side lengths between the angles, then that's enough information to guarantee that these two triangles are congruent. But what if you didn't know that these angles, over here and over here, were matching, but instead you knew that these two angles, up here and over here, were matching? So this isn't angle-side angle anymore because the purple side length is no longer between the two blue angles. If we go around the triangle, then we know that they have matching angle, angle, and side. So instead of angle-side angle, we say these two triangles have matching angle-angle side, or AAS for short. And the question we'll be asking here is this: if triangles have matching AAS, or angle-angle side, is that enough to guarantee that the triangles are definitely congruent? To figure this out, suppose these two angles have measure A and these two angles have measure B. Then in terms of A and B, how many degrees are in each of these green angles over here and over here? Exactly, these green angles both have measure 180 degrees minus A minus B. So we started out knowing these triangles had matching angle-angle side, but that means these triangles also have matching third angles. If we don't worry about angle B, then you might notice that these two triangles must be congruent according to one of the postulates you already know. Which one is it? SSS, SAS, or ASA? Right, these two triangles are congruent by angle-side angle, or ASA. So whenever you have two triangles with matching angle-angle side, they're definitely congruent to each other. So here are the four congruence postulates: side, 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 angle, side, angle, side, angle, and now angle, angle, side, which you found is a result of angle, side, angle. If you're wondering about other combinations of matching sides and angles and whether they also guarantee congruence, we'll be looking at a few more in later lessons. For now, let's double-check AAS by making your own triangle. So here's a triangle, and this angle measures 30 degrees, this angle measures 100 degrees, and this side, opposite from the 30-degree angle, has length 2. Now over here, you can use this interactive to make all kinds of triangles by dragging these three yellow corners around. With this interactive, try making your own triangle with angle-angle side that matches this triangle on the left. Once you have one, press the Submit button up here. Great! So here's another example of a triangle with angles that measure 30 and 100 degrees and a side of length 2 opposite from the 30-degree angle. And sure enough, this triangle looks the same as the one on the left. It's just rotated a little bit, but they're still congruent. So matching angle-angle side is enough to guarantee that two triangles are congruent. Okay, last question. Take a look at this triangle here, with angles of 60 degrees and 75 degrees, and the side opposite the 75-degree angle has length 6. So you know angle-angle side for this triangle. Which of these triangles down here are congruent to the triangle up here? And here's a hint, there's more than one. Nicely done! Going around this triangle, we have a side of length 6, a 60-degree angle, and a 75-degree angle. So does this triangle, 6, 60 degrees, 75 degrees, so it must be congruent. And this triangle is also congruent, and we can see that by flipping it around. These other two triangles also have a side of length 6 and angles of 60 and 75 degrees, but they're arranged in different ways. For this triangle, the angles surround the side, so you can see it's not congruent. And for this triangle, it's the 60-degree angle rather than the 75-degree angle that's opposite from the side of length 6. So when you're comparing triangles, pay close attention to those matching sides and angles. To get started, go ahead and identify which two of these triangles are similar, or click down here to review. Exactly, these two triangles are similar. They have the same overall shape, but different sizes. Now in this lesson, we'll be looking at the angles of similar triangles. First, take a look at this angle over here. Which angle in this triangle appears to be congruent to this one? Right, so it turns out that these two angles are congruent. And which angle appears to be congruent to this green angle? Precisely, so these two angles are also congruent. And this third angle down here turns out to be congruent to this angle over here. In general, if you ever have triangles with three matching pairs of angles, they must be similar to each other. Let's test whether that's really true. Here's a triangle whose three angles measure 70 degrees, 65 degrees, and 45 degrees. Over here, try making your own triangle whose angles measure 70, 65, and 45, and then press the Submit button over here. Nicely done. So here's another example of a triangle whose three angles measure 70, 65, and 45 degrees. And sure enough, these two triangles are similar. So whenever triangles have three pairs of matching angles, they're definitely similar to each other. But what if triangles only have two pairs of matching angles? Well, take a look at these two triangles. Suppose these angles both measure 75 degrees and these angles both measure 55 degrees. Before we check if these are similar, do you remember what the three angles in every triangle always add up to? Right, they always add up to 180 degrees. So then what are the measures of the remaining angles in these two triangles? Exactly, they're both 50 degrees. So even if triangles have two matching pairs of angles, they have to be similar, because if triangles have two matching angles, their third angles must also be the same. And this fact about angles and similarity is known as the angle-angle postulate, or AA for short. Next, try using the AA postulate to determine which of these triangles down here are similar. Exactly, these two triangles are similar. They have two matching pairs of angles. Next, let's look at three more triangles. At first glance, it doesn't look like any of these triangles have two matching pairs of angles. But remember, once you know two angles in a triangle, you can figure out the third angle. So try finding the missing angles for these triangles and then determine which of them are similar to each other. Excellent work! If these angles measure 80 and 54, and all three angles add up to 180, that means this angle must measure 46 degrees. And this angle here measures 57 degrees, and this angle measures 80 degrees. So that means these are the two triangles with matching angles, so they're similar. Finally, here are two similar triangles. Suppose these corresponding sides have lengths of 8 and 12. Let's look at this pair of corresponding sides. If this side has length 10, then how long is this side over here? Feel free to ask for a hint if you get stuck, or click over here to review solving for side lengths in similar shapes.